video we're going to be looking at how to deal with dependent uncertainties. So remember that dependent uncertainties are uncertainties that arise from the same source. So often this can happen because you've used the same piece of equipment to make these measurements. Now if you want to add or subtract two values with dependent uncertainties, then you need to add the absolute uncertainty. So let's consider an example of this. Imagine that you want to calculate the volume of liquid that's been added to a container, and you do this by subtracting the initial volume from the final volume in the container. So you've used the same scale on the side of your jug or container to measure the volumes. So in this case, these two volume measurements are dependent. Let's say that the final volume was 60 plus or minus 5 millilitres and the initial volume was 20 plus or minus 5 millilitres. Then in order to calculate the volume of liquid that's been added, we simply have to subtract the 20 from 60, which gives us 40 millilitres added. Now in order to calculate the uncertainty in this, we just add the two uncertainties from the two individual cases. So that's 5 millilitres plus 5 millilitres, which gives us 10 millilitres. So the volume of liquid added is then given as 40 plus or minus 10 millilitres. Alternatively, we may want to multiply or divide numbers with a dependent uncertainty. In this case, we need to add the percentage uncertainties in order to get the percentage uncertainty in the product of the two numbers. So for example, imagine that we had a disk and we wanted to work out what the surface area of the disk is. In this case, to calculate surface area, we're going to need to make use of the formula that the surface area is given by pi r squared. So what we can do then is we can measure the diameter of the disk. So let's say that we measure the diameter of this disk and we measure it to be 10.00 plus or minus 0.05 centimetres. In this case, the surface area is given by pi r squared, which is equal to pi, the diameter divided by 2, all squared. And so this is pi times 10.00 over 2 squared, which on the calculator gives us 78.54 centimetres squared. So we've now worked out the surface area. Now we need to work out the uncertainty associated with that surface area. So we're going to need to add all the percentage uncertainties involved. So delta A on A is going to be equal to delta pi on pi plus delta R on R plus delta R on R. Now pi is just a number. This number is known exactly, which means that there's no uncertainty in the pi. So delta pi is equal to 0. And so we end up with delta A on A is equal to 2 delta R on R. So we've now got our uncertainty in terms of the radius. But what we actually measured was the diameter rather than the radius. So the radius is equal to the diameter divided by 2. And so just using that rule again, the uncertainty in the radius over the radius is equal to the uncertainty in the diameter over the diameter plus the uncertainty in 2 over 2. But there is no uncertainty in 2. It's an integer and everybody knows exactly how big it is. So the uncertainty in 2 is 0. So the uncertainty in R on R is the same as the uncertainty in the diameter over the diameter. So substituting this back into our original equation for the uncertainty in the surface area, the uncertainty in the surface area divided by the surface area is equal to 2 delta diameter over the diameter. So this is 2 times 0.05 on 10, which is 0.01. So 0.01 times 100 is going to be our percentage uncertainty in the surface area. So we can now work out the absolute uncertainty in the surface area. We can just do the 0.01 times 78.54, which gives us 0.79 as the uncertainty in the surface area. So remember, we will present that with 2 decimal places as we calculated the surface area with 4 significant figures, which ended up having 2 decimal places, and we want our uncertainty to have the same number of decimal places as our value. So the surface area in this case would be 78.54 plus or minus 0.79 centimetres squared. So just to summarise, if you want to add or subtract 2 values with a dependent error, you need to add the absolute errors to calculate the total uncertainty, and that gives you the absolute uncertainty. If you want to multiply or divide 2 values with a dependent error, then you need to add the percentage uncertainties in these 2 values, and this will give you the total percentage uncertainty.